19, 20, and 21, we are evaluating an exponential function that has a base of e. E is kind of like pi. It's one of those standard values that always is the same number. It's an irrational value. On your calculator, on the Casio calculator, in order to calculate e, you're above the natural log button. The natural log button's way on the end that says ln. You'll see right above it in yellow is e to the x. So to calculate e, you hit shift, natural log, it puts the e there. Now if you have a Texas Instrument, you have to put parentheses around it. On the Casio, you don't really need them unless you're doing some other operation like adding or multiplying, but it doesn't hurt if I put parentheses around the 1. So what it looks like on my calculator is just e parenthesis 1. I'm not putting a caret key in there for the exponent, which to me seems kind of weird, but that's how the Casio works. E to the first power should give you 2.718 and so forth and so on. So 2.71 is approximately the value of e. And we're going to do some calculations that have formulas that have base e in them. So it says, the number of bacteria, P of t, in a certain population increases according to the following exponential function where t is measured in hours. So again, here we're starting with a population of 190. This is compounding continuously at a rate of 8% for t hours. So we want to find the amount after 3 hours. So what we're going to put in is 190. We got to do the e, which means you have to hit shift ln. And then right behind the e in parentheses, we're going to do 0.08 times 3. So 190, shift, natural log button, you should see the e on your calculator, parentheses, 0.08 times 3, close my parentheses, and I get 241.5. We're rounding it to the nearest gram, so 242 is where we want to round that off to. Same thing we're going to do, but now we're going to do 8 hours. So we're going to start with the 190. We want the e in there, 0.08 times 8. So 190, shift, natural log, in parentheses, 0.08 times 8, close my parenthesis, and I get 360.3. So rounding to the nearest gram, 360. So I started with a population of 190. It's increasing at 8%. After 3 hours, I have 242. After 8 hours, I have 360. It's slowly getting bigger and bigger and bigger. Number 20, it says, suppose that the velocity v of t in meters per second of a skydiver falling near the Earth's surface is given by the following exponential function, where t is measured in seconds. So, 54, 1 minus e to the negative 0.24 t. The initial velocity is when your time is 0. So I'd have 54, 1 minus e, and then in parentheses, the negative 0.24 times 0. And so I have to close my parenthesis for the e, close my parenthesis for the regular set of parentheses that's on there. Well, this is going to give me 0. E to the 0 power, or anything to the 0 power, is 1. 1 minus 1 is 0. 1 minus 1 is 0, and 0 times 54, still 0. If I'm a skydiver and I haven't even jumped out of the plane yet, my velocity is going to be 0. Now just for fun, let's punch that into our calculator and see that we get the same thing. So 54 parenthesis, 1 minus, shift, natural log to get the e, parenthesis, negative 0.24 times 0, close my parenthesis for the e, and close my parenthesis for my other parenthesis, and if I hit equals, Indeed, I get 0. The skydiver hasn't even left the plane yet. After 5 seconds, 54, 1 minus e to the negative 0.24 times 5. Now this one we'll have to round off, so of course we have to use our parentheses. It doesn't come out nice. So, 54, parenthesis, 1 minus shift natural log, parenthesis, negative 0.24 times 5, close my parenthesis again, hit equals. I'm getting 37.7, rounding that off, 38. So now he's falling 38 meters per second. And then the last one, we have this crazy fraction. It says, a species of animals is discovered on an island. Suppose that the population size P of t of the species can be modeled by the following exponential function, where t is measured in years. And so first of all, we want to find the initial size of our population by putting 0 in for the time. So we're going to take 400, and since we have to divide that by a whole bunch of stuff, we either have to calculate the bottom of the fraction first, or we have to put it in parentheses. So 1 plus 7e, and then again parentheses around, are negative 0.1 times 0. So if we figure that out, 400 divided by parentheses, 1 plus 7, shift natural log, parenthesis, negative 0.1 times 0, since I'm doing the initial, parenthesis, and I get 50. My initial population is 50. This would give me 0. E to the 0 is 1. 1 times 7 is 7. 7 plus 1 is 8. 400 divided by 8 gives me 50. It was just as easy to use my calculator. After 8 years, the only thing we're going to change is the 0 to 8. So 400 divided by 1 plus 7e, parentheses, negative 0.1 times 8. Close my parentheses up. So 400 divided by parentheses, 1 plus 7, shift natural log, parentheses, negative 0.1 times 8, close my parentheses, and I get 96.4, so 96 would be my population after 8 years. So, initial population size when it was discovered was 50. 8 years later, it was up to 96.